Welcome. Let us discuss today few problems on hyperbola. The first problem is the eccentricity of the conic passing through the point of intersection of root 3x minus y minus 4 root 3k is equal to 0 and root 3 kx plus ky minus 4 root 3 is equal to 0 for all values of k is options root 2, root 3, 2 root 2 and 2. The problem here is that two straight lines are given in which k is an unknown quantity. We have to find the eccentricity of the hyperbola which passes through point of intersection of this and that. It has two ways. Simplest one is from this and from that you find k in terms of x, y and known constants. Similarly from there, equate these to k, then we will get a relation involving x and y. So let us do it first. From this we get k is equal to root 3x minus y divided by 4 root 3. Okay, root 3x minus y in that side and it is 4 root 3. Okay, from this it is equal to actually k into root 3x plus y is equal to 4 root 3. So that k is equal to 4 root 3 divided by that root 3x plus y. Now equating these two values of k, we get root 3x minus y by 4 root 3 is equal to 4 root 3 by root 3x plus y. Now by cross multiplication, this is 3x square minus y square is equal to this into that 16 into 3, that is 48. So that it becomes a hyperbola. Its standard form is x square by 16 minus y square by 48 is equal to 1. Now problem is we have to find the eccentricity of that hyperbola, that is eccentricity of this hyperbola. Formula is ready and eccentricity is equal to root over of 1 plus b square by a square 48 divided by 16, so that it is 3, 1, 4, root 4 is 2. So this is answer. And this is the first technique. Other technique is from these two, very easily we can solve for x and y. X will contain k, y will contain k. From these two relations x and y, eliminate k. And you get the same result like this. Exactly same result, and answer is that. You can try it yourself. Next problem. The eccentricity of the hyperbola conjugate to x square by 16 minus y square by 12 is equal to 1 is root 13 by 2 options, root 14 by 2, root 7 by 2, and root 7 by 3. We have to find eccentricity of a hyperbola, not of that, its conjugate hyperbola. We know that hyperbola conjugate to that is, we have to simply replace 1 by -1, and it would be y square by 12 minus x square by 16 is equal to 1. This is hyperbola conjugate to that. And very easily we can find its eccentricity. It is actually equal to E is equal to root over 1 plus this by that, b square by 12, this by that, so that it is equal to root over of 1 plus 4 by 3, 7, it is root over 7 by 3. So this option is correct. Next one. C is center. Oh no, not that. It is x square by 25 minus y square by 6 square is equal to not 6. Y square by b square, b square is equal to, okay, is equal to 1. Passes through the point 5 root 3, 3 root 2. Distance between its two directrices is options 25 by root 34, 50 by root 34, 16 by root 34, and 32 by root 34. Achha, this is a hyperbola in standard form, but one unknown is there, which is b, and this hyperbola passes through that point. So very easily we can obtain the value of b. A is already given, b can be obtained. But from this we can very easily obtain the distance between two directrices, and we know that distance between two directrices is 2a by e. So eccentricity a is given. Knowing b, very easily we can obtain eccentricity. Now putting here, we get answer. Now for that purpose, this hyperbola passes through that, so it will satisfy it, so that it is 25 into 3 x square by 25 minus y square, that is 9 into 2 divided by b square is equal to 1. So that 18 by b square is equal to 25 cancels, 3 minus 1, that is 2. So that b square is equal to 9. B square is 9. So A is known, B is known, eccentricity can be obtained. Eccentricity is equal to root over of 1 plus b square by a square, that is 9 by 25, so that it is equal to root over 34 by 5. Root 25 is 5. Okay, this eccentricity is that. And we have to find out distance between two directrices. From origin, length of distance of directrices is a by e, so it is 2a by e. So it is equal to 2 into a means 5 by e, root 34 by e. So that 50 by root 34 is the answer. This is correct option. Next problem. C is center, S dashed are focus of the hyperbola x square minus y square is equal to 20. If P is any point on the hyperbola, then to find the value of SP into S dashed P, value of this. And options are, all are in terms of root 2 into Cp square, 2 into Cp square, Cp square, and root 3 into Cp square. This is a hyperbola. This hyperbola is, you see, A and B both are 20. Therefore, root 20. A and B are both root 20. So it is a rectangular hyperbola. And for rectangular hyperbola, its eccentricity is always root 2, whatever be the value of that. Because it is equal to x square by 20 minus y square by 20 is equal to 1. Equation is that. So eccentricity E is equal to root over of 1 plus b square by a square, 20 by 20 again 1, so that root 2. Without any calculation, whatever be the value of that, for rectangular hyperbola, eccentricity is that. Now the problem is, I draw it first. This is a branch, this is another branch. S is focus, S dash is focus. This is one directrix. Another directrix is this. P is any point on that hyperbola. SP, we have to find the value of SP and multiplied by S dashed P. Product of SP and S dashed P we have to find. From this, perpendicular is drawn on directrices. Suppose they meet at directrices at M and M dashed. This must be a straight line, same straight line, and this straight line meet the y-axis, say at the point Z. So we get SP is equal to E into PM from definition. S dashed P, it will be E into P M dashed. Means from P, perpendicular is drawn to the corresponding directrix, P M dashed. So we get SP into S dash P is equal to E into Pm plus Pm dash is equal to E means root 2 E into Pm Pm is equal to Pz plus Zm plus Pm dash. Oh, sorry. Pm is equal to Pz minus Zm and Pm dash is equal to Pz minus Pm dash is equal to Pz plus M dash Z. This. It is, oh, not that. Pm is equal to Pz minus Zm. Pm dash is equal to Pz plus M dash Z. Okay. Now suppose coordinate of P is x1, y1. So x1, y1 must satisfy it. That is x1 square plus y1 square is minus. It is equal to 20. Now here it is equal to E into Pz. I'll put it here or there. Matter is same, almost same. So Pm, oh, I have mistaken. At one point I have mistaken. This is E into Pm, Sp, and S dash P is E into Pm dash. Into. So that E square is your 2 into Pm. Pz minus Zm into Pm dash. It is equal to Pz plus Zm dash is equal to 2 into Pz. It is actually x coordinate of Pz. So x1 minus Zm. Zm is equal to, let it Zm into x1 plus Zm. It is Zm, Mz dash and Zm are same quantity. Zm. So that it is equal to 2 into x1 square minus Zm square, Mz square. It is equal to 2x1 square minus Mz square. Mz is equal to A by E because it is Mz is the distance of the directrix from y-axis. So it is A by E. So A square by E square into that 2 is equal to 2x1 square minus E square is again 2, cancels, A square is your 20. So this is equal to, this one is equal to x1 square minus x1 square minus 20, x1 square plus x1 square plus x1 square minus 20. x1 square minus 20, x1 square minus 20 is y1 square. So that plus y1 square. x1 square means that x1 square, y1 square is this is y1, so that it is cp squared. So answer is cp square, this one. That is third option is correct. Now, the next problem. Equation of the chord bisected. Equation of the chord of x square by 12 minus y square by 8 is equal to 1, which is bisected at the point 5, 2 is. Sixty options. 60x minus 36y minus 151. 36x minus 60y minus 51 is equal to 0. Then next one is 60x minus 36y minus 115 is equal to 0. 36x minus 60y minus 15 is equal to 0. So the problem is, one hyperbola is given, this hyperbola, and this is a branch, and 5, 2 is a point over here. 5, 2. We have to find the equation of the chord which is bisected at that point. Like that, say this is the chord, say it is bisected at that point. Like ellipse, we know that equation of any chord bisected at any point is given by t is equal to s1. T is the, as if the equation of tangent of that conic at that point, and this is t, tangent, and s1 is the value of the conic at that point. Now say, so s1 is equal to x1 square means 25 by 12 minus y means 4 by 8 minus 1, so that it is equal to 25 minus by 12 minus half minus 1. It is equal to 26 at 12, 18, 7. So perhaps it is 12, 7 by 12. And equation of tangent t is equal to, how to obtain? I told you that if it is square term, write it as x into x by 12, y minus y by 8 minus 1, so that it is, and after that replace one x by x coordinate and other x coordinate x intact, and same case for y, so that it is equal to 5x by 12, x is 5 minus 2, so 2y by 8 minus 1, so that it is equal to, this is 4 actually, multiplying Oh, this is tangent, so this is equal to 0. This is equal to 0. It is actually equal to uh, 1 by 12, 5x by 12 minus multiplying by, so that it is equal to 4, that is 3y by 12 minus 12 by is equal to 0, so 12 can be cancelled. So that we get this is equal to 0. Hence, we get t is equal to s1 means 5x minus 3y minus 12 is equal to s1 is your 7 by 12. So multiplying by 12, we get 60x minus 36y minus 144 minus 7 is equal to 0. It is 151. So that 60x minus 36y minus 151 is equal to 0. That is, this is the correct option. Next one. The next problem is the parametric coordinate of the point 8, 6 on x square by 16 minus y square by 12 is equal to 1 is 4 sec pi by 4, comma 6 tan pi by 4. Second option, 4 sec pi by 6, 2 root 3 tan pi by 6, 4 sec pi by 3, 2 root 3 tan pi by 3, and 4 sec 2 pi by 3, 2 root 3 tan 2 pi by 3. The question is very simple. This is a hyperbola. One point on it is given that, you see, it must satisfy it. It is 84, 64, 4. This is 36, 3. 4 minus 3 is 1. Okay. This is a point on that. We have to find the parametric form of that point. We know that for any point 8, 6, parametric form of that can be taken as A sec theta, means 4 sec theta, and B is your 2 root 3 tan theta. So that we get this is equal to 8, this is equal to 6. So 4 sec theta is equal to 8 and 2 root 3 tan theta is equal to 6. We have to find one theta which satisfies both this and that simultaneously. This can be from this, it is 1 by cos theta. So cos theta is equal to half. 1 by cos theta, so cos theta is there, 4 by 8 half. And from there, tan theta is equal to this by that, 2 3 root 3. Now very easily we see that theta is equal to pi by 3 satisfies both this and that. So theta is your pi by 3. So this option is correct. Next. The distance between a focus and corresponding directrix of the hyperbola 16x square minus 3y square minus 32x minus 12y minus 44 is equal to 0 is options 4 by root 19, 3 by root 19, 16 by root 19 and root 19. Now this problem is in that problem one equation of hyperbola is given, not in standard form, and then after finding it in standard form, to find the distance between a focus and its corresponding directrix, like that. Suppose this is one branch of the hyperbola, this is a focus and this is corresponding directrix. So we have to find SZ. This is actually, we know that it is AE comma 0. This is x is equal to A by E. So that we have to find the distance between this to that. So AE, that distance minus this distance, AE minus A by E, that is A into E minus 1 upon E. So we have to find what is A and what is E. From this equation we get 16 into x square minus 2x minus 3 into y square, taking minus common, plus 4y is equal to 44. Now put here 1 so that it become a perfect square. 4, it become perfect square. So actually I have taken 16 more here. So plus 16 and minus 12 there. So adjust. So that we get 16 into x minus 1 whole square minus 3 into y plus 2 whole square is equal to 48. So that we get x minus 1 whole square by 16 by 48, 3 minus y plus 2 whole square by 16 is equal to 1. This is now in standard form. Its focus is, first of all we find E. E is equal to root over 1 plus b square by a square, so that it is equal to root over of 19 by 3. Okay. Now focus. Focus actually is given by In standard form, it is x is equal to AE, but here it is not x. X minus 1 is equal to AE, that is x is equal to 1 plus AE. This length is 1 plus AE, and equation of directrix is in standard form, it is x is equal to A by E. Here, x minus 1 is equal to A by E. That is, x is equal to 1 plus A by E. So, our distance, actually the distance between focus and that equation of directrix is same, because 1 and 1 will be cancelled. So, it is actually AE minus A by E. So it is AE minus A by E. So A is your root 3 into E. E means root over 19 by 3 minus A taken 1 by E, root 3 by 19. So that it is equal to root 3 into, they together is 19 minus 3 by root 3 into 90. Root 3 into 90. Root 3 cancels, so that it is equal to 16 by root 19. That option is correct. Next. Next problem is for all t for the point 40, comma 2 into root over of 16t square minus 1 is a point on the hyperbola. The length of its latus rectum is options 1, 8, 4 and 8 by 3. So it is a problem is like that. One hyperbola is not given, but one point on it is given. That point in terms of parameters. If we take x is equal to that and y is equal to this, after eliminating parameter t, we can get the equation of hyperbola in Cartesian form. Let us try for that first. So x is equal to 40, y is equal to 2 into root over 16t square minus 1. So that y square is equal to 4 into 16t square. 16t square means x square minus 1. So equation become x square minus 1 is equal to y square by 4. So that x square minus y square by 4 is equal to 1. Now it becomes a hyperbola in Cartesian form. A square is equal to 1, b square is equal to 4. And we have to find the length of latus rectum. The length of latus rectum is 2 b square by a. So that 2 into b square means 16 divided by a means 1. B square means 4, sorry. This is b square. So that 8 by 1, 8. So option B is correct. Okay. I request you, if you feel that this is helpful for you, then please like it, share it, and subscribe it. Thank you.